right, so let's first start. I get these slides all the time. I don't know the particular details of this event, but it does say food, which I know people like. So when is that? I think that's Wednesday, 4:30 to 6 in the Trate building, 1090. Apparently you can hear about computer science, what a great major it is. I know I'm very biased because now I have 2 degrees and I'm getting a 3rd degree in computer science, but computer science is a really useful major. Every time I talk to someone, whether it's biology or physics or social sciences or anything, they always say, yes, I know how to program a little bit because I need to do it as part of my work. Everybody nowadays is programming. So it's very useful if you have a major, because you'll get all these courses in programming and all of the things we talk about, performance, stuff like that. But I have a whole discussion on that. Probably the last lecture of the term, I'll talk more about future steps in programming, the courses available at McGill, and projects you can work on for programming. So we'll leave that for a little bit later. Okay, there is midterm viewing. It's today, it's from 3 to 5, and it's in this building, room 321, so it's up a floor and then over a bit. So we'll have that for 2 hours today. And then if you can't make it, we'll figure out a time, another time to do something. Maybe it'll be office hours. If lots of people couldn't make it, then we'll do another big viewing party. Okay. Please excuse my voice today. It's a little bit rough. Okay. So just to recap what we did before. So I just want to make sure that you guys saw this. I apologize if it's not exactly what Julia showed you. So we did talk about overloading. So having 2 methods with the same name, and you can have that as long as both methods or multiple methods, they have different parameters. So usually we use that for different constructors. So I showed you, I think we talked about this on Wednesday. I showed you how you can have 2 add methods. Here we have one add method int A and B, and another add method double A, double B. And Java figures out the types. It's very lazy, so it prefers to call the int version when it can, so it doesn't have to do any conversions. So here we're trying to add 2 ints, so it's going to call the int version. Here it's trying to add 2 doubles, so it will call the double version. But here you can see we say that we overload the method. We have 2 methods, same name, but different parameters. And I showed you guys this example. If you have a multiply method and 2 versions of the multiply method and they both take integers, Java gets confused. It goes, hey, you can't do that. That's not overloading. You're confusing me. I won't know which version to call, so it doesn't work. So if you change the return type, or you make one of the versions static or non-static, that doesn't matter. Java will still get confused about which one to call. So again, the rule is that they can have the same name, but the parameters have to differ. Okay, and I showed you this where it's most useful. Actually, perhaps I didn't show you this. Did Julia show you this? The painting? Okay. So here we have 2 constructors for the painting. This is usually why we have overloading. We have one painting where we can construct it, where we know the artist, we know the value. And then we have another constructor where, okay, we don't know the artist. We just give it a value, and we set the artist to be unknown. So here are the 2 different ways of calling the constructor. One, you give it 2 parameters, and the other version, you just give it 1 parameter. And based on the parameters, because one is a string and a double, and the other one is a double, Java is able to figure out which version to call. Excuse me. Okay, any questions about that? Okay. All right, and you guys also saw the toString method. The toString method is super helpful. Usually, when you make your own class and you print it out, just system.out.println, and then you print your instance. Before you make a toString method, Java is pretty useless with this. It gives you the class name and it gives you an address. So what we do is we put inside the class, we put a toString method It has to be public string to string, and then it returns a string, so that's where you put in all your details. So after you add this to the painting class, whenever you print out an instance of painting, you'll get this nice string printed. So then you can see all the details, and this is super, super helpful for debugging. Because debugging, when you're just looking at stuff like that, pretty much useless. But it's, debugging with that, it's not too bad. And then you can change this to provide whatever details you want. So that's the toString method. You just need to put in your class, public string to string. It returns a string with all the details. Questions about that? Okay. Yep.
The toString method originally is what? Is here you're overloading it, right?
It originally just prints out the class name and then @ and then the address. That's what it prints out. Okay. And then we had this. This is needed for your assignment, having an array of paintings. It's very, very similar to an array of strings. Here we have a painting array. PR is new array of paintings, 3 paintings. We can use arrays.toString and pass that array of paintings. And what this is doing is it's printing out null or toString on each instance. For example, here in the second spot, in the middle spot of that painting array, I create a new painting by Picasso that's worth $10. I print out that painting array using toString, and what happens is that arrays.toString method, it goes along that array of reference types, and it either prints out a null or it prints out the toString value of each instance. So to say that again, when we have arrays.toString and we call it on an array of reference types, it will either print null or it will call the toString method of each instance. So here we put Picasso's painting in the middle spot, the middle element in that array. So the first spot is still null. The second one, that's my painting instance. And then the third spot is null. So again, once you define a toString method in your class, it becomes much easier to get all this debugging information, and then we can use arrays.toString and just print out these arrays of our instances. Okay. I also had this array of paintings. So we can do something like here. We have 3 paintings, Starry Night, Sunset, and Nighthawks. So by Van Gogh, Unknown, and Hopper. We place those paintings into a painting array. Here I'm using the bracket notation just to place them directly in there. So it's an array of 3 paintings. I'm calling a method and I'm passing this array of paintings. Inside this method, it's the max value method. You've seen this a few times, including on the midterm. So we assume that the first one is the best painting, the painting with the best value. We iterate through, and if the painting at I, if its value is larger than our best painting not value, then we store the best painting and return it. So here we're doing a bunch of things. We're storing paintings in an array using the braces notation. We're passing that array to a method. That method is iterating through that array of paintings, and what you can do is you can access the attributes of those instances if they're not private, or you can call methods on those instances. So it's very, very, very similar to doing something with strings, and that's because strings are reference types and paintings are also reference types. Okay, questions about that? Okay, all right, so let's talk about an apartment example. So you guys saw last time, you guys saw people where people had best friends, right? Okay, so this is very, very similar to that. Where I want to get to is I want to create an apartment class, and I want to have rooms connected to each other. So for example, we can have a living room, and the living room will be to the north of the kitchen. And we'll also do some stuff with length and width for each room so that we can have all of our rooms in an array, and then we can calculate the apartment's total area. And where I want to get to is adding in a player here, because assignment 5 should be out within a few days. And assignment 5 has a loop so that you as the player can move around. So it'll be very, very similar to this example. Okay, so I'm going to show this map because this map took me hours and hours to draw. It's a little map of how we're going to connect some rooms together. So we'll have a room, say it's the kitchen. The kitchen, there might be rooms to the west, east, north, and south. So here we can see that the living room is to the north side of the kitchen. And for some reason, the bedroom is floating off here in space. So it's not quite connected yet. So we're going to start defining these connections between rooms, the same as we said before. If you have a person, they have a best friend. Okay, so let's start writing this. And let me load up IntelliJ. Sorry, I should have done this before. Okay. I have so many different folders here. Okay. Let's do, you will be the room. You will be the apartment. Okay, so in a room, ignore the package code 2 for now. Please ignore that. Let's just have, in case we need it, let's just have arrays. And within a room, we'll have a private double width and a private double length. And let's also have, for each room, we're going to have a name. So now, let's create a constructor for this room. So what we need a name, we have a width, and we have length. Pardon me, I was doing some Python, and you don't need to put the types there. Okay, so let's just use the this syntax to set the attributes. So again, this.name refers to the attribute name, and then when we just have name here, it refers to the parameter name. So this is how to properly set the attributes in your class. This.length is equal to length. Okay. And what do we want to do with this? We also want to have a simple little method, get area. This will return the width times length. And I do want to point out here a very common problem that people have when they're doing programming is, can anyone tell me what unit this width and length is? Is it feet? Is it meters? You don't know, because I haven't written it. So make sure to use consistent units, meters, feet, in your programs. That's kind of a thing, a little bit about more program design, something we're not going to talk a lot about, but I thought I would just raise it now. That's part of the documentation, is to say, okay, here's the width of the room, here's the length of a room. You need to make sure that anyone who's using your code knows, okay, we're dealing in meters, we're dealing in feet, stuff like that. There being a ton of cases. I think there was with NASA, they were doing, I think it was a Mars lander, and part of the people who were working on it were working in metric, and part of the people who were working on it were working in imperial. So what do you think happened? it smashed into the planet and totally broke and totally pointless, and they wasted $1 million like creating a crater on Mars. So the point is, you have to make sure when you're working with people, you have to make sure, okay, we're all using metric, and we're all using meters, or we're all using centimeters, stuff like that. It's a really big problem in programming to make sure that your units are consistent. Okay, so I'm just going to leave a little comment here. Anyone reading my code, then they'll know that when I talk about width and length, it will be meters. Okay. So now we have some rooms. Let's just quickly create a little apartment by joining some rooms together. So we'll have a room K, so it'll be a new room kitchen, and my kitchen 2 meters by 2 meters, whatever. We'll have another room, the living room, my living room is 1 meter by 1 meter. I'm a poor grad student. Okay, and while we're here, why don't we create an array of rooms, not mu, new room 2, so we'll have 2 spots, and then we'll say rooms 0 is K, and rooms 1 is the living room. Okay. So very exciting. Okay, we have an array of rooms. We've created some rooms, put them inside. Let's make sure that this runs. It does not run. So it's still not going to run. Pardon me. I'm just going to delete some other files. Delete anyway. I'm sure nothing will go wrong. Oh, come on. Okay. Pardon me. I'm going to delete all the files and assume that nothing is useful. I'm sure that won't come back to bite me at all. Delete everything. Delete anyways. Okay. All right then. That's how I solve problems, by doing things. Come on. Pardon me. Going to talk about cat spas later. I'll have to delete those. Okay, there, and then it shows up. All right. So can anyone tell me, sorry about that, can anyone tell me what happens if I use array.toString to print out this array of rooms? Import java.util.arrays. Can anyone tell me what this is going to print out right now? Yeah, the address. Because we haven't yet defined the toString method on our room class, so it's just going to give us this ugly little code. Again, please ignore the package code2 for right now. That's just because of the way I have my directory set up. So let's get something a little bit nicer. Let's have our toString method. And we're just going to return the name, this.width, Put an M in there just to make sure that we know we're talking about meters. Okay. So there, it's super nice. I love having two strings because once you add the two strings, it's super easy, public string to string, and then you just return a string. Then whenever you print out your arrays or anything, you get this really nice representation. Okay, we have a kitchen and we have a living room right there. Let's also while we're doing this, let's do a quick little iteration through the rooms, and we're just going to sum up. Room R is equal to rooms at I. So we'll iterate through all the rooms in our array, and then we'll add up all of those areas. So just iterating through and summing up the areas from each room, where we do room.getArea, and then we'll print out the total area. So in my, see again, you have to tell the user what units you're working with so that everyone's on the same page. So just put a little text in there. So now you know, okay, my apartment is 5 meters square. I'm probably paying too much for it if it's only 5 meters square. That's okay. All right. So now we have our. I've shown you how to construct things. I've shown you the toString, how to put things in an array, and how to call methods on things in an array. It's very, very simple. It's just iteration through. What I really want to get to is I want to have something here where we'll have rooms connecting to other rooms. So let's have a reference within each room. It's going to have a reference to the room that's to the north of it, to the south of it, to the west and the east. Now these are private, so we'll have to have some setter methods. This.north is equal to north. Pardon me while I copy and paste this. South, 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 south. West, west. I wish I could detect that I'm doing this and be a little bit smarter so I didn't have to do this. But anyways, okay, so now we have our private rooms, north, south, west, east, and we have some setter methods for them. So here we have one room, our kitchen, our living room. Let's add one more. Let's add a bedroom, just to have it more interesting. How big is the bedroom? I don't know. 50 meters by 50 meters. And we'll put that in our array. Rooms 2 is equal to bedroom. All right. So now we have some rooms. Why don't we start setting some directions between them? So let's do K set north LR. So what I'm doing is I'm saying, okay, from the kitchen, the room to the north of the kitchen is the living room. Does that make sense to everyone? Okay. So if I run it now, it wouldn't do anything. So what I'm going to do, let's just do this, change our toString a little bit, just so I can have a little bit more return S. And then we'll do s plus equals north. So we'll have, when we do a toString of an instance, we'll say, okay, what's each room, what's the size of each room, and then what's the name of the room to the north. So this is a way of building up our map of the rooms. North. And I don't have a get name yet, do I? Okay. So this is what usually happens. You figure out, okay, I need to get the name of a room. So you quickly add a getter. So public string get name, because a name is a string. So we just quickly return a string, return this.name. It's a quick little getter. And now we can use that down here, get name. Okay. So can anyone see what the problem is with this code right now? If I'm trying to access the name of the room to the north, what could happen? Yep.
If it doesn't have any room to north, it will fail.
Yep. What error am I going to get? No pointer exception. Great. No pointer exception. Yep. I'm trying to access if this.north, if there's no room to the north, that's because the default value of a reference type is null. So when you create this instance in the constructor, you haven't done anything with it, all these rooms get a value of null. So then when I try to do get name on something that's null, Java doesn't like that, so it's going to crash. So how do you guard against that? You have all these not equal to null checks in your code. So if this.north is not equal to null, then we can print out the name. Why did that not work? Oh, because I did it after. Okay. What's after we create the rooms? Then we'll set that to north. Okay. So here we have the kitchen, and then the living room is to the north. So it quite a few steps to get there. We have to have in each room, we have to have references to the rooms to the north, south, west, east. They're private, so we need to add some setter methods for them. And then in our toString, we need to check to see if a room is null before we can print out its name. Again, you can't access any methods or any attributes of something that's null. It will crash on you, give you a null pointer exception. Okay. So I don't want to spend time, but you can see how to extend this. You'd have to call set north, south, west, and east to connect all these rooms together. And then in the toString, you would just repeat that a bunch of times, and then you could print out what's the south, west, east of each other. Okay. Any questions about this before I move on to adding a player on top of this? Yeah?
We can verify if it's null or not in the getters and setters instead.
In the getters and setters. You mean verify that that's not null?
Yeah.
No. It's a good idea what you're thinking, but it's the very act of calling a method on null. That's what crashes it and gives it a null pointer exception. So as soon as you do .getName, that's what's going to crash it right away. Okay. Let's quickly add a player class. And the reason I want to have a player class is so that we can get a little game loop going, because that's what you're going to need to do in the last assignment. So let's have a little player. It's pretty simple. You'll have a name. And just for speed, we're going to have a current room. So again, a constructor. Okay, so a player has a name and a current room. So let's create them. Player P is a new player, and I'll just have my name, and they will start in the kitchen. And what I'm going to do is I'm going to set up a little scanner. So it will hide it on me because I'm not using it yet, which is super, super annoying. Let's set up the scanner, and then I'll put the import back in. Scanner is a new scanner, and it takes some system.in. So pardon me, Java util.scanner. So we'll have a scanner, and then we'll do a while loop. We'll have some input. We'll just have some empty input. And then while our input is not equal to quit, it's a string type, so let's do the proper comparison. Make it simple. So we're going to repeatedly get some input from the user, and while the input is not equal to quit, we're going to do something. So we're going to print out, enter a command, and then get the input from the user. So scanner.readline. Why or not? Next line, pardon me. And then we'll have some conditions. So if the player enters north, then we're going to call a method on that player, else if input equals south, p.goSouth. So I haven't created these methods yet. I will in a second. If you don't understand, so this is always very helpful, is to have a last little case. If you don't understand the input that someone has put in, something's wrong, just say, I don't understand the command, so the user can see that they made a typo. Okay. So what I want here, I have a quick little while loop that while our input is not equal to quit, we're going to get a command from the user. If it's equal to north, we're going to call go north on the player, which I haven't built yet. If it's south, we're going to call go south on the player. Otherwise, we're just going to print out I don't understand the command. So what do we want to do with these go north and go south commands? Well, we are going to have the current. Oh, I need getter methods, don't I? Okay. We are going to, from our current room, we're going to move into another room. So let's break this up into two separate lines here. So I'll have to get the room to the north of our current room. That means I need to have a getter, get north, return this dot north. Then we'll just print out out.println player entered well, they have a name. This dot name entered this dot current room dot get name. Okay. So there is our go north method. So what it does is that the player is in a current room. It says, okay, can I get the room that's to the north of my current room? And then it simply sets the current room to be that room to the north, and then it will print out which room the player entered. Let me just quickly do the south version. 2 seconds. That is totally wrong. Okay. And then I just need to do a getter. So you can see in your code, a lot of the time you have a ton of getters and setters. That's just what happens. All right. So let's run this, and I'll put it down here so you can see the code. So it says enter a command. What did I start them off in? I started them off in the kitchen. To the north is the living room. So if our command is north, I entered the living room. Very exciting. All that work for me to move from the kitchen to the living room. So I just want to show this as a basic little, just a short little demo of creating. Here we have 3 classes that are communicating. We haven't done that before. We have rooms that contain references to other rooms. Has a constructor. It has a ton of getters and setters, which are, this is the basic version. This is what they look like. We have a toString method. If you're doing this kind of references stuff, you have to make sure that you check for null. We also did a get area, where we can easily, where it's just a little calculation for the width and length of a room. Here we have a player, they have a name, and they have a current room that they're currently in, which is very, very similar to last assignment. Here's a constructor for creating them with a name and a current room. Here's some code. When you call go north on a player, they get the room to the north of the current room, set it, and then they print out a statement. Same thing with go south. So I leave it as an exercise to you to do go west and go east. And you also need to do some null checks here. So the room to the north might be null, so you might need to check for that. And here I just wanted to go through, create some rooms, put them in an array, calculate the total array of the rooms. And here we create a scanner. We get some input from the user here. And while it's not equal to quit, then we do something based on that scanner. So it's very, very, very similar to what we did in tic-tac-toe. Based on what our input is, we call different methods on our player. So you guys will be using that on the 5th assignment. You're calling methods on the player, and that player then does things, and they may or may not have a reference to another class. So there's lots of calling between these 3 classes. Okay, obviously this isn't complete, and I don't want to spend too much more time on it, because I do want to talk about something else in the last 5 minutes. Pardon me. But I do want to say there are many ways to extend this, and again, creating a game is a great way to learn things. So what you could do is you could create another class item, so you can add items to the room to pick up and use. For example, you could have notes that can be dropped in each room that you can write yourself. Create a class for monsters, so both characters have randomly calculated damage. Or just have a bunch of rooms and have the player go through the rooms, give you lots of experience with handling null. So here, have a maze where they need to visit different locations before they win. Okay, I just want to spend 2 seconds talking about data structures, and then this is something that we'll talk again on Wednesday. So I've shown you how we can use classes to store and organize data. So that's a very, very important thing in computer science and programming. So for example, we have arrays, but arrays are very inflexible because as you've seen, they can only store one type of element, and they have to have a fixed size. So what we're going to do is we're going to talk about more flexible data structures in the future. And where I want to get to in the next class is talking about a dynamically sized array class. And then we'll get to array lists, which remove lots of the problems that everyone has with arrays. And then in the future courses, we'll talk about data structures. So we have stuff like stack, which is like if you're at a buffet, you have like a stack of dishes that you take one and push down, stuff like that. So in a stack, you can only grab the top plate, and when you put more on, then you can only grab the top plate again. There are things like queues, where it's like a supermarket queue, where the first person who gets seen is the first person who entered that queue. And we have stuff like trees. In computer science, we do a lot of searching. So we build up a lot of trees. For example, in chess, you can say, okay, from the chessboard, what happens if like this one moves here and this one moves here? Or like, what if this moves here and this moves here? And you can build up like a move tree to see all the different possibilities of how that chess game might evolve. Okay, so I'm going to stop there, and then next time we'll look at the code for dynamic arrays. Thank you.